In this video, we look at the Stanford Math Tournament problem. This is the integral from negative pi over 4 to positive pi over 4 of x plus pi over 4 divided by 2 minus the cosine of x. So here I'm going to use like two methods. The first one, I'm going to use what we call the King's rule of definite integrals, which is the integral from a to b of f of x dx is the same as the integral from a to b of f of a plus b minus x dx. This is the King's rule, right? I'm going to use this one for now. So this, our integral, is going to be the integral from negative pi over 4 to positive pi over 4. So let's find out what a plus b minus x here is really in this question. So a is the lower limit, which is negative pi over 4. B is the upper limit, which is positive pi over 4 minus x. So that evaluates to 0 minus x, and that is equal to negative x. So it means I'm just replacing x with negative x in the original integral. And that is negative x plus pi over 4 divided by 2 minus the cosine of negative x dx. This integral and this integral are the same, right? So that is equal to the original integral. So I from the King's property is the integral from negative pi over 4 to positive pi over 4 of negative x plus pi over 4 divided by 2 minus cosine of x is an even function. So the cosine of a negative angle is the same as the cosine of the positive angle. So that is the cosine of x dx. So what I'm going to do now, what is obvious, is to sum the two integrals and hope for the best. So this is the original integral I plus the I that is being transformed by the King's property, which is I in yellow, and this is equal to what? So the original integral is the integral from negative pi over 4 to positive pi over 4 of x plus pi over 4 divided by 2 minus the cosine of x. That is the original integral, that is this one. Okay, now plus the one that is being transformed by the King's property, they are the same. This is the integral from negative pi over 4 to positive pi over 4 of negative x plus pi over 4 divided by 2 minus the cosine of x dx. They have the same limits of integration, so I'm just going to sum them. Okay, so summing them, the left hand side is 2i, so the limits of integration is negative pi over 4 to positive pi over 4 for both. I beg your pardon, there's the x here, sorry about that. So that is going to be x plus pi over 4 all over 2 minus the cosine of x plus negative x plus pi over 4 all over 2 minus the cosine of x. So one integral. We have now put our two integrals into one integral, so this is going to be, because they are now of the same denominator, we just have to sum the numerators, right? And summing them, x will cancel with negative x, and you are going to have the integral from negative pi over 4 to positive pi over 4 of pi over 4 plus pi over 4 is pi over 2 over the common denominator, which is 2 minus the cosine of x dx. And this one, pi over 2, is a constant. It goes in front of the integral. And that is the integral from negative pi over 4 to positive pi over 4 of 1 all over 2 minus the cosine of x dx. With the, now this one now, what I will do here is to use the tangent half angle substitution. So we call it the tangent half angle substitution. Half angle substitution. Tangent half angle substitution, which states that if we let t to be equal to tan of half of an angle, let's say x over 2, this one, the cosine of x can be written as 1 minus t squared all over 1 plus t squared. And an expression for dx in terms of t is 2 all over 1 plus t squared dt. This is the tangent half angle substitution. So we are just going to plug that into our integral, but then let's find the change in limits, right? When x is negative pi over 4, that is the lower limit of integration, we have t to be equal to tan of pi over 4, that is going to be tan of negative pi over 4 over 2, that is tan of negative pi over 8, like this. And that is equals to negative of the tan of pi over 8. Because tan is an odd function, so when x is positive pi over 4, we have t to be equal to positive tangent of pi over 8, like this. Now let's substitute this one into our integral. So our integral 2I is really equal to pi over 2. The integral, the limits will now change from negative tan of pi over 8 to positive tan of pi over 8 of 1 all over 2 minus cosine of x. Cosine of x can be written like this, which is 1 minus t squared all over 1 plus t squared times dx, and dx can be written like this, which is 2 over 1 plus t squared dt. Now the task now is to simplify this integral. So 2I is pi over 2, the integral from negative tan of pi over 8 to positive tan of pi over 8 of 1 all over, simplifying this one out, is 2 plus 2t squared minus 1 plus t squared, right? Times 2 all over 1 plus t squared. This all over 1 plus t squared here, dt. So 2I is the pi over 2, the integral from negative tan of pi over 8 to positive tan of pi over 8 of 1 all over this one, and this one will cancel. Now we have this is now 2 minus 1 here, which is 1, and 2t squared plus t squared is 3t squared plus 1 times 2 dt. This 2 is a constant, it goes in front, which will cancel up with this 2. We are left with pi in front here. The limits will be pi over 8 to positive version of pi over 8 of 1 all over 3t squared plus 1 dt. So what I can do is to divide the denominator by 3 and do the same thing to the numerator, right, to maintain equality. So this one is going to be dividing by 3 is going to be pi, the integral from negative tan of pi over 8 to positive tan of pi over 8 of 1/3. And 1/3 is now a constant at the numerator, which I will bring it out here. It should be pi over 3, 1 divided by t squared plus 1 over 3 dt. So 2I is pi over 3, the integral from negative tan of pi over 8 to positive tan of pi over 8 of 1 all over t squared plus 1 over 3 can be written as 1 all over the square root of 3 all squared dt. And I'm going to compare this one to the arctan integral, which is the integral of 1 all over x squared plus a squared dx. This one is 1 all over a tan inverse of x over a. So this one is like the arctan integral, so I am going to use that to solve this integral. So 2I is going to be pi over 3, and now integrating is going to be 1 all over a here is 1 over the square root of 3, and then the arctan, or the tan inverse of x here is like t divided by a, which is 1 over the square root of 3. The limits of integration are negative tan of pi over 8 to positive tan of pi over 8. 2I is going to be equal to this one is going to be the square root of 3 over 3 pi over 3, and then tan inverse of the square root of 3t from negative tan of pi over 8 to positive tan of pi over 8. Alright, so 2I is going to be the square root of 3 pi over 3, and then you plug in your upper limit. That is going to be tan inverse of the square root of 3 tan of pi over 8 minus the tan inverse of this one. That is going to be the tan inverse of the negative square root of 3 tan of pi over 8. But tan of a negative angle is negative of the tan inverse of the positive angle. So 2i is going to be the square root of 3 over 2 square root of 3 over 3 pi, right? And then this one is the tan inverse of that, and this is going to be the negative of the tan inverse of the positive angle. So the negative will come out and nullify this negative, which will be plus. And now I just summing two of these guys. So that is going to be 2 times the tan inverse of the square root of 3 tan of pi over 8, like this. So in the end, you have to divide by 2. So dividing by 2, divide by 2, this one will cancel this one. And that is going to be I to be equal to the square root of 3 over 3 pi here. And then tan inverse of the square root of 3 tan of pi over 8. So this one is the value of our integral. So therefore, if we integrate from negative pi over 4 to positive pi over 4 of x plus pi over 4 divided by 2 minus the cosine of x dx, this one evaluates to the square root of 3 pi over 3, and then tan inverse of the square root of 3 tan of pi over 8, like this. This one, ladies and gentlemen, is the value of our beautiful integral. So if you find this helpful, make sure to give me a thumbs up, subscribe to my channel for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.